In this video, we're going to look at transforming the parabola. To begin with, we're going to look specifically at turning point form. So when any parabola or any equation is written in turning point form, it takes the form of y equals a bracket x minus h squared plus k. Let's have a look at what a, h and k are. Okay, so to do this, I'm using GeoGebra. So I've put in the general form of y equals a bracket x minus h all squared plus k. And at the moment, a, h and k are just set at the value of 1. Now let's just go to looking at what a actually does. So a is that letter in the front of the formula. Now look at how the graph changes. As a gets bigger and bigger and bigger and bigger, the graph appears to be thinning. And of course, let's go the other side. Let's go a smaller and smaller and smaller. So it was set at 1. There's 1. If I go smaller and smaller, just below 1, look, the graph appears to be widening. Now, it will let me go as far as 0.1, apologies. Obviously, I'm using decimal places of 0.1. As soon as I go to 0, it's a flat line. And then it goes into negatives. And you can see that gives us our negative parabola. And of course, numbers between negative 0.1 and negative 1, obviously a bit wider, and then of course as we get more and more negative, the graph gets thinner and thinner and thinner. So I'll just take that back to 1, and we'll have a look now at how h affects the graph. H is that one inside the bracket. Now if I make h bigger, the bigger the number, the more positive the number, the graph moves to the right. If I make h negative, okay, you can see the graph moves. You can see h is obviously that horizontal shift. All right, now let's have a look at the vertical one, the k value. Well, I've already given away what it's going to do, but let's just check I'm right. So as k gets bigger and bigger, the graph goes up. Graph goes down. You can see it's that vertical shift. Now what you're going to be studying is a combination of all these. A, h and k are obviously going to change. Let's make some notes. So we're going to call A the dilation factor, and I've written here that obviously widens or thins the graph out. So I've written if A is greater than 1, then the graph is thinner, and obviously if it's between 0 and 1, the graph gets wider, and then when A is negative, it's actually reflected in the x-axis. And I've done just a couple of sketches of what that looks like and what we discovered when we looked at the GeoGebra slider. And you can obviously pause the video and make some notes. Now, the next thing we looked at was the vertical shift. Well, actually, looked at the horizontal shift, but that's the way I've written it. And when the vertical shift, when it was greater than 0, the graph moved up by k units. And when it was negative or below 0, it moved down by however many units. We then looked at the horizontal shift. Now, the horizontal shift is really, it's the hardest one of all, because when h is greater than 0, we're actually moving the graph h units to the right. And when h is less than 0, we're moving the graph h units to the left. Note that the horizontal shift only occurs when the coefficient of x is 1. So you might be in a situation where you may have to factorize to make sure that that coefficient of x is 1. Now, one of the most important things about being in turning point form is that hk, if we take the value, the letter h and k, that gives us the coordinate of the turning point for the turning point on any graph. Coordinate of the turning point. So I'll just give you a couple of examples on how we do that. So we're going to state the turning point of the graph y equals 2 bracket x minus 1 squared plus h. You'll notice that the h value is 1, even though the negative belongs to the 1. Remember, in our general form, it's got to be minus h. So h is just 1, and the k value is 8. So the turning point, the turning point is 1, 8. It's not letting me write, which is frustrating. Turning point, there we go, is 1, 8. And you can check that on a ClassPad or any graphics calculator. Let's do a second example and look at some of the changes that have been made. So, for example, state the changes required to turn y equals x squared into y equals 2 bracket x plus 3 squared minus 4. So let's write down that a equals 2. Well, that tells us this is a dilation factor of 2, so therefore the graph is thinner. H is negative 3, so therefore the graph has moved 3 units to the left, and K is negative 4, so that tells me that the graph has moved down by 4 units. We also have a turning point at negative 3, negative 4. Don't forget that tells us our axes of symmetry, if we were required to give the equation, is the line x equals negative 3. So next example, find the equation of a quadratic with a turning point of 4, 2 and a y-intercept of 0. So let's just write down that the turning point is 4, 2. So that's our value of hk, remember. And our coordinate for the y-intercept is 0, 0, 0. So let's just write down also, so h is 4 and k is 2. And I always like to write the turning point equation down, and then I can just substitute the values in. So you can see I'm writing down the turning point form, and I'm going to sub in, well, we don't have any knowledge that there's a value of a, but we can't assume there isn't a value of a. So all I'm going to do is substitute what I know. So I'm substituting in the hk first. So I've got y equals a bracket x minus 4 squared plus 2. Now I also know that I'm going to use the y-intercept, so I can sub in when x is 0, y is 0. So 0 equals a bracket 0 minus 4 squared plus 2, and I'm literally going to go and solve to find out what the value of a might be. So solving gives me 0 equals a times negative 4 squared plus 2. Negative 4 squared is 16, so I've got 16a plus 2, move the 2 over, negative 2 equals 16a, so therefore a equals negative 2 over 16, which cancels down to negative 1 over 8. Therefore we can finish that off by saying the equation of our graph is y equals negative 1/8 x minus 4 squared plus 2.